Today we're going to look at combining some information from section 3.2. We've been solving systems algebraically using substitution or elimination. Today we're going to focus on how do we choose which method is best and then apply a few to some word problems. So for substitution to be the best, we want a system where one of the equations is already solved for a variable. Like in this first example, we already have y equals, so it would be an easy substitution. If we're going to pick the elimination method, we want an equation or a system of equations that are both in standard form. All right, so let's look at our first example here. Because we have our first equation already solved for y, we can make a substitution. We can dump this in for our y in our second equation. So our second equation becomes 2x plus 3 times our y equals negative 8. And we said y is equivalent to 2x minus 4. So we did a substitution. Now we can simplify. We're going to distribute, and then we're going to combine like terms. All right, adding 12 to the other side, we've got 8x equaling 4. And then dividing out our 8, we have x being 1/2. 4/8 is the same as 1/2. Now we can go back and substitute that in for x to figure out our y value. So y is 2 times our x, which was 1/2, minus 4. Well, 2 times 1/2, or half of 2 is 1. 1 minus 4 would give us a y value of negative 3. So our point of intersection for these two lines, the solution to the system, would be x being 1/2 and y being negative 3. For our second example, we said this fit more with an elimination process because we have both equations in standard form. We can get opposite coefficients pretty easily for our x's by multiplying the second equation by a 2. So the first equation, 2x minus 2y equals negative 10, didn't need to be changed. The second equation would be negative 2x plus 6y, and 2 times 19 would be 38. Now when we add them together, our x's drop out, our y's end up being 4 of them, negative 2 plus 6 is 4, and adding 38 with the negative 10 is 28. So when we divide out our 4 now, we know y has to be 7. And now we can dump that back in. Again, it doesn't matter which equation we plug it into. It has to work in both. But let's say we plug it into the top one. So 2x minus 2 times y, which is 7, has to equal negative 10. So 2x minus 14 equals negative 10. We'd have to add the 14 to move it to the other side. So 2x now equals 4. And if we divide out our 2, we have x equaling 2. So the solution for this system would be 2, negative 7. Sorry, 2, positive 7. All right. Let's look at a couple examples of where we might make use of a system of equations. It says, suppose you're at the store and you want to buy some fruit. Oranges are 80 cents and bananas are 50 cents. You buy 9 total pieces of fruit and pay $6. How many of each fruit did you buy? So the first thing you want to do is figure out what are you being asked to find and figure out some variables for that. So let's let x equal the number of bananas that we buy, and y can be the number of oranges. Then we have to set up a system of equations. Now, notice that there are two different totals. One total just tells me how many pieces of fruit I'm buying, and the other involves how much it costs, the money. So let's look at just how many we are buying. We said x stands for the number of bananas I buy, and y stands for the number of oranges. If I add those together, it says I bought 9 total pieces of fruit. So one of my equations would be x plus y equals 9. The second equation deals with the cost. It says that oranges are 80 cents and bananas are 50 cents, and we pay a total of $6. So for every banana that we buy, we're going to pay 50 cents. For every orange that we buy, we're going to pay 80 cents, and our total bill is $6. Now, we can solve this using substitution or doing an elimination method. Either one would work. Let's go ahead and try a substitution method. We'll take our top equation and solve for either x or y. It would not matter. Let's say we solve for y. We can subtract the x to the other side. So we'd have negative x plus 9 is equivalent to our y. And now we can make a substitution. We can plug that in for our y value. All right, making that substitution, we'd have 0.5 or 50 cents for each x, 0.8 times our y value, which was negative x plus 9, equals 6. Multiplying or distributing that 0.8, we have negative 0.8 times x, and here we have 0.8 times 9. Well, 8 times 9 would be 72. So 0.8 times 9 would be 7.2. Combining like terms, we have 0.5 minus 0.8, or negative 0.3, plus 7.2 equals 6. We'd have to subtract the 7.2. So we have negative 0.3x equaling negative 1.2. And then if we divide out our negative 0.3, it's really like 12 divided by 3. We've got x being 4. So that means we bought 4 bananas, and now we will plug them back in, and we can plug it in right there. So our y value is negative 4 plus 9, which would be 5. So to answer our question here, we bought 4 bananas, and we bought 5 oranges. All right, let's look at another example. Here we have a student has some $1 and $5 bills in his wallet. He has a total of 11 bills. So again, one of my totals is just the total number of bills in his wallet, and it's worth $31. So one of my totals is the total value of the money he has. How many of each type of bill does he have? So again, we're going to have 2 variables. We can let x be the number of $1 bills in his wallet, and y can be the number of $5 bills in his wallet. So total of 11 bills means if I take all the $1 bills, x, and all the $5 bills, y, I have a total of 11 of them. The value of them is $31. So let's think about that. Every $1 bill is worth $1. Every $5 bill is worth $5. So I would have the equations x plus y equals 11 and 1x plus 5y equals 31. That is the system I have to solve. Now notice that these are in standard form. Doing an elimination method would be pretty easy because we could multiply one of our equations by a negative 1 and get some opposite x's. So my top equation becomes negative 1x minus 1y equals negative 11. My second equation didn't change at all. When I add them together, the x's drop out. I get 4y's equaling 20. So y equals 5. That means I have 5 $5 bills. All right. We are trying now to figure out how many $1 bills. Boy, my board is just not working out here today. 5 $5 bills. Okay. Let's plug that back in. We have x plus 5 has to be 11. So subtracting 5, we have x being 6. So I must have 6 $1 bills. All right, so five $5 bills, 6 $1 bills adds up to my 11 bills in the wallet. And 5 times 5 is $25. 6 times 1 is 6. If I add 25 and 6, I do get the $31 that I was told. All right, our last one says, you and your best friend have lemonade stands and decide to start a competition. This is actually one of the questions we looked at earlier in the chapter, but there we solved with graphing. So we're going to look at how we would solve it algebraically. It says you already have $30 and you make $5 per day. So your total money, we'll let X be number of days and Y can be the total money we make. All right, so my total, it says I already have $30 and I'm adding to it $5 per day. So for every day, I'm going to get another $5. My friend has $21, but is adding $8 every day for X days. In how many days will you have the same amount? So it's asking us to figure out where our totals, where our Y's would be equivalent. So this really is a substitution. We can substitute this in for that Y. So my amount, 30 plus 5x, has to be equivalent to my friend's amount, 21 plus 8x. And now it's just a basic linear equation to solve. Let's subtract 5x to the other side. So 30 equals 21 plus 3x. We can subtract 21. 30 minus 21 would be 9. 9 equals 3x. When we divide, we have x being 3. So after 3 days, we will both have the same amount. Now let's figure out what that amount is. If I put 3 in for x, I have 30 plus 5 times 3. So 30 plus 15 would be $45. So after 3 days, we will both have $45 total. Okay, now we can check that again, plugging it in there. 8 times 3 is 24, adding with the 21 they already have. So both of us do have $45 after those 3 days. All right, you are going to be working on section 3.2C worksheet.